Nice. Okay. Well, today topic is FHRP. Okay. What is redundancy? First, we will discuss FHRP. Before that, we will discuss redundancy and how the network architecture is available in architecture and real time. The companies maintain, organizations will maintain which kind of architecture. So first, I'll explain those things. Then we'll move to the FHR. First of all, see, as we discussed earlier, we have a access layer devices and its access layer devices have connected to end users. As we discussed, the access layer devices are the connected to directly end users as servers. Anything you can assume. This is a server or again end users are IP phones and laptops and you can assume like it's kind of Wi-Fi devices. So here we have a Wi-Fi device. So it's a Wi-Fi device, and this Wi-Fi device to connected again access layer devices, and this Wi-Fi is provided to us likewise reachability. So anyway, this is the access layer devices, access layer connected to end users. These all are the end users, hosts and servers and AP ports, whatever you can assume. So this is the basic level of architecture at land location, land. So this land is again local area network is connected to again our distribution layer devices. So these are the distribution layer devices. So likewise, it's high availability means have one and two. It means it's primary and secondary. You can assume that it's primary and secondary. One is goes down, we have a secondary device. So that is the reason we need a redundancy devices in our network architecture also. The connectivity likewise. So entire connectivity likewise. So these are the also connected likewise. How many access devices are directly it will be connected to our distribution layer. So it's our distribution it's our distribution layer and this one is our access and access again connected to, as we know, the core devices. Okay, these are the core devices. So these core devices are connected like this. Edge devices. Otherwise, if it's two-tier architecture, so this one is only the core and as well as access. If so, it's kind of L3 devices will use. So here we'll use L3 devices. So this is the two-tier architecture, and this one is a three-tier architecture. If this is not assumed like we haven't core device, so core is like it will be these are the core devices. No, these are the core. So why I am explaining the layer because we have to know where and which devices we use. So in access, we'll use 1K or 2K series switches, and in distribution, 3560 or 3550. This kind of devices we'll use, and these are the switches. And in core devices, is the edge devices where we'll use purely edge devices. It means we'll use like Cisco routers, all are the routers. Here we'll use and 4K series router or 5K or Catalyst, Catalyst 9K. So these are the devices. Catalyst 9K. These are the Catalyst devices. Catalyst switches or Catalyst and Nexus switches. Those will use in edge level. But these are the Catalyst switches are will use here. Sorry. This routers will use. These are the routers. All are the edge routers. Edge router So here we'll use core switch set. In that switch also, it's 9K series, 9K catalyst switch, or 5K or 7K. Those are the catalyst switches. Okay. Okay, fine. If now forget about the core layer. Now we'll discuss two-tier architecture. So these are the real-time architecture. Now move forward. I'll come back to the same scenario. Before that, I'll show you in brief about the how the connectivity happened with. So just now I am taking only one device to connect it our LAN network. So the network flow will really happen. If the redundancy is not there, what the issues will be happen, we'll discuss. Okay. So here, as I told, it's a core distribution device, and distribution is directly connected to our access devices and LAN network, and LAN network is connected to multiple users. So everything is fine, and these are the host PCs are users. So this user is connected to one IS. So because we need to reach out internet, our final goal is internet. We should have to reach internet. If we are not able to reach internet, it means we cannot able to communicate our and branches, different branches also. So we need our final goal is internet for Google subject. Google.com. If we will reach the Google.com means we can use any kind of applications. So these are the requirements. So what we will do, the connectivity is one ISP is there. You can assume like anything. It's BSNL. So it's our government site BSNL. BSNL is providing services very well. So and it's our core router. And router is connected to switch, and here it's kind of our LAN network, and LAN having multiple prefixes. But here I am taking only one network, anything 192.168 dot some one dot something 10 or one. It's default gateway of LAN users 255.255.255.0. In this, it's kind of we have a 254 users. In this IP prefix, we have its kind of class class C IP address. So here we have a 255 users we can use in this prefix in this network. So everything is working fine. No, this user got the IP address through DHCP or something to 1.10, and this IP address is 192.168.1.20, and this user got the IP address 1.30 something. Okay, they can able to reach LAN to WAN easily because the entire connectivity is working fine. So what happened? Some physical connectivity issue or this BSNL provider issue, service provider issue. Something happened. So this link is goes down. So we can able to reach the ISP is down, the WAN connectivity is down. Something happened. So we cannot able to reach internet. So our LAN users, if we have a three users, then it's little bit issue. If you are working in bank sector or some big size of organizations, let's assume so entire users, these are the multiple users. Just now I have mentioned we have access switches. These many access switches are connected to users. These are the access layer switches. These are the access layer switches connected to core device. So now tell me WAN is down. So they can able to not reach if we have another branch here. Let's assume this ISP is connected to again our another branch. We have a different branch, different location, and different. those lands having here it's kind of our data center, and the connectivity is like WAN to our, this is a different location. So whenever we need ISP, internet service provider only provide to us reachability. There might be it's kind of service internet, it kind of service provider. Two types of service providers we have. ISP. One more is SP. SP it means only service provider. They are providing the reachability. And ISP means internet. Internet. They are providing the internet. It means Google something. So two types of reachability they will provide. One is ISP, other one is SP, service provider only. So now in this case, we have a SP. This one is the SP service provider, and this one is the ISP link. So both link they provide. So SP to connect it to our data center. It's a kind of our data center, and data center we hosted
अ,
entire our
अच्छा सो
service.
के उठा मैं थोड़ा सा.
Pardon?
हाँ, आवाज कम कर दिया आप लोगों ने.
Guys, mute yourself.
नहीं नहीं
So
नहीं,
it's
वो
kind of data center. In the data center,
मेरे
we
उसमें
have
थोड़ा क्लास में था हम बस.
work organizations website abc.com, something abc.com, whichever, wherever you are working, those hosted on our cloud or something else, they can utilize some whichever the applications they are hosted in data. So
बच्चों की.
the link is goes down. Then tell me they cannot able to reach either internet also or either data center also. So this kind of issues, how we'll resolve it? How we will resolve it? This kind of issues. Now, if I'll take one more ISP. So because sometimes BSNL is not providing us good service. So we'll take another service, another ISP. I have taken Geo service provider now. So it's kind of private sector. Okay. I have taken the Geo service provider. So now tell me, BSNL, it's kind of 4G service they are providing, and Geo is providing us a 5G services. So it's 4G and it's kind of 5G service. So compared to 4G, 5G is best. So here we are getting the service is like 1 Gbps speed, 1 gig speed. 1 gig means 100 MB to 1000 Mbps. 1000 Mbps we are getting here, and here we are getting 4G means here we are getting 100 Mbps. 100 Mbps speed only. So I'll take this is as a redundancy part. I'll take once Geo went down something issue, physical issue, something. I'll use it's a kind of secondary for secondary link as a BSNL. It's a secondary link, and this one is my primary link. I'll use. So for primary part, I make sure always because here I am getting the 1 gig service and here I am getting the 100 gig service, 100 Mbps speed. So compared to 4G, 5G is best. That is the reason I always will use this one is the primary service. So for that, I need active and standby routers. So I need if I can use both this both if see if here one link is goes down, no issue. We have another redundancy. We can able to reach SP also, ISP also. Internet also we can reach, and we can reach our services also. So now tell me if this router is goes down. So some issue, some technically some devices issue or something happened with this router, power issue, power failover, then entire router is goes down. This router is goes down, then I cannot able to reach the Google, or I cannot reach the entire LAN to WAN because the physical issue is there. Physical connectivity, it means the device, entire device is failover. Some CPU is gone. Power issue, something happened with this device. So same issue. So what I will do, and this time I'll use the redundancy devices. So that is what here, as I mentioned, we have a primary and secondary. Two devices in real time we use likewise. Two devices. and two ISPs. Like it's kind of multi-home network. It's kind of multi-home network. So this is my LAN. LAN is connected to again. These are my edge routers, edge devices. Edge devices are connected to my LAN switch. It's my switch, and this one R1 is my primary, and R2 is my secondary. I'll use this one is the secondary device. R2 is my secondary device. So now these devices are connected to ISPs, right? So it's my BSNL ISP. So it's kind of my BSNL ISP, and this one is my Geo ISP. And again, they are connected through redundancy path. So this is the way we'll use. So you can use entire thing. This is my WAN connectivity, and this one is my LAN connectivity. If one ISP is also goes down, this ISP or this cable, this router is goes down, we have a one ISP also, second ISP also. We can utilize both ISPs because we have a multi-homed environment. Here, single homed environment. It's kind of single homed environment, and this kind of multi-homed environment. This is a multi-homed environment, multi-homed device. If one router also goes down, no issue. One ISP also goes down, no issue. But entire this connectivity goes down also, no issue. Because of we have a redundancy path. We have a redundancy path. That is what. If we want to achieve, if I want to configure, if I want to make a possibility, so we need a redundancy protocols. So we need a redundancy protocol. So here we have a FHRP, first hope redundancy protocols. So here we have a first hope redundancy protocols. So these are the first hope redundancy protocols we have. So we'll discuss step by step what are the first hope redundancy protocols, how it will be configured, how will where will configure, how the groups will work, what is the priority, entire thing we'll discuss. So this is the my LAN networks. So in LAN network, I can able to reach entire thing. So if this ISP goes down, also no issue. And if this physical connectivity router also goes down, no issue. Because we have a redundancy path. If you have any queries, then ask me. So, chalo. Now move to FHRP. How it will be work? What is here again in FHRP? We have a three types of protocols. Basically, first hope redundancy protocol. It is a first hope redundancy. It's a family actually. In this family, we have again three types. Three types. What are those three types? First one is HSRP, and second one is VRRP, and third one is GLBP. So, what is HSRP? Hot Standby Router Protocol. Hot Standby HSRP stands for Hot Standby Router Protocol, and VRRP stands for Virtual Router Redundancy Protocol, and GLBP stands for Gateway Load Balancing Protocol. Load balancing. Only we can achieve the load balancing and GLBP only. Now we'll discuss each and every protocol here. So let's see. In my screen is visible, right? Guys, can you confirm it?
Yes,
Yes.
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 Right. So first of all, in FHRP stands for First Hope Redundancy Protocol. and redundancy attempt to eliminate a single point of failover by providing duplicate devices and links. So as we discussed here, so here you can check in this my network in these four devices, we have a if this is you can assume now if one ISP goes down, single point of failover, it's kind of single point of failover. We need a duplicate devices. Means we need a standby routers. So that is what we need a standby router. Then only we can achieve. Then only we can able to reach. Then only we can able to reach LAN to WAN. So that is what. So here we have a three types: hard standby router protocol, virtual router redundancy protocol, and gateway load balancing protocol. And in this, we have a HSRP and GLBP, gateway load balancing protocol. These both are Cisco proprietary. These both are Cisco proprietary, and this one only VRRP only the protocol. It's open standard. It means so if you are using the Cisco devices at both devices active and standby, then only you can utilize this protocol. Otherwise, if you are using HP, Aruba, Palo Alto, something different vendor devices, so we have a different vendor devices. So in market, you can see so HP and Palo Alto, Fortinet, these are the vendors. They are providing the router as well as switches. They are providing. So comparison to different vendors, why everyone will teach you Cisco only because Cisco only the vendor in market, they distribute up to 60%. So every organization, wherever you will see, so mostly in every organization, 50 to 60% of devices Cisco own. So that is the reason we have a certifications also mostly CCNA, CCNA, LP, or CCIE vendors also some likewise in whenever you are giving the interviews, the time they will ask you the do you have the CCNA certificate likewise only. So that is what. So Cisco having every protocols. So Cisco having they have all are the Cisco standard protocols like EHRP in routing we have, and this is the L3 protocol again. Don't forget if someone asks you HSRP or VRRP, GLBP, in which layer protocols? It's important question. In which layer FHRP will work? HSRP will work in which layer? So they will work in layer 3. Don't forget. This is not a layer 2 protocol. Again, it's a layer 3 protocol. And where and what is load balancing? At a time, we can utilize multiple links. So here, as I mentioned, one and two links that are we have here. At a time, we cannot utilize multiple links, multiple ISPs. It will be possible only in Cisco protocol, Cisco proprietary protocol that is GLBP, Gateway Load Balancing Protocol. Name itself, you can assume it's a gateway load balancing protocol. And we can achieve here only load balancing. Here, no load balancing. And here also no load balancing. Yes, if we want, yes, load balancing we can achieve based on the LAN network. Based on the LAN network, we can achieve. If someone asks you, are you sure we cannot able to achieve load balancing in HSRP, VRRP? No, not likewise. We can achieve the load balancing. As you know, in earlier we discussed STP, spanning tree protocol. In that, one more version is there. That is in STP, we have a one Cisco vendor protocol uh, per VLAN PVSC per VLAN spanning tree, and we have another one is P PVSC plus also two types of here we have in that will how a two types of these are the Cisco proprietary again. PVSC and PVSC plus both are Cisco proprietary. So here you can check per VLAN spanning tree. So every VLAN we have a different instances. That time we can achieve whenever you are creating the logical interfaces. whenever you are creating the VLAN interfaces, that time yes, you can achieve the load balancing also in this VRRP and HSRP. Apart from that, directly you cannot achieve. Whenever you are using the physical interfaces, that time you cannot achieve the load balancing. Whenever you are using logical interfaces, yes, that's only if you are using VLAN, if you are using VLAN, that time you only you can achieve the load balancing. Otherwise, if you are using load balancing, then yes. If you are not using, so whenever you are using VLAN, virtual local area networks, VLANs in virtual interface. If you are using physical, no. Physical interfaces means no. Basically, type it right, make it as a no only. So it's advanced level. So multi-cost group. In this multi-cost group, we have a two types of HSRP having two types of version one and version two. In this version one, the multi-cast IP address is 224.0.0.2 and 224.0.0.102. And here also 102 because this one also Cisco proprietary and this one also Cisco proprietary. That is the reason. This one also Cisco proprietary and this one also Cisco proprietary. That is the reason 102. And in this version 2 only we have 102. And based on this multicast IP address, they will send hello timer, any updates. If any updates like which one is the active router, which one is the standby routers, any updates, all the updates will share through multicast group IP address. So this one is the IP. And this is a class D IP address. I hope, I believe everyone knows what is multicast IP address. So multicast means it will be send a group of communication, one to group of communication. And here is a multi-cost group IP addresses to send the port number. They will use the port numbers. Based on the port numbers only, they will use the entire. So what is port number? Actually, based on the port number, we can identify the services. We can identify the services. So they will use UDP port numbers. All the services are used UDP port numbers only. We can identify the services through port numbers only. We can identify services. So what services? So HSRP service, VRRP service, GLBP service. So based on these port number, we can create whenever we are creating the if we want to deny or if we want to permit through ACL, that time we'll identify the service. That is what port number. So here they are using the UDP port number, user datagram port numbers. So UDP is a unreliable protocol. It always send the update. It won't wait for the acknowledgement. So these are the identify the service through port numbers. The UDP port number of HSRP 1985 and VRRP port number is 112 and GLBP port number is 3222. So here hello timers of HSRP and VRRP GLBP. So HSRP and GLBP both are the Cisco proprietary. That is the reason timers are same. And hello timer every 3 seconds they will send my neighbor is alive or not. And if they will wait for up to 10 seconds, if neighbor is not alive, then they will drop the packets. It means standby will become the active. What is standby and what is active router? We'll discuss. Before that, here we have a timers. So here we have a advertisement 1 second master downtime and 3 advertisement timers and SQA timer. It will be sequential timer for 254 priority. It will be based on the formula. It will be calculated timer. So but the timer of 1 second only it will be master router and if master is went down, it will be based on this formula, it will be calculated the timers. So based on the 254 by minus priority. So by default, what is priority we discuss. So based on that, it will be elected. But here the timer will be hello timer is 3 seconds and 10 the whole time one timer is still it will be wait for a neighbor up to 10 seconds. If neighbor is not giving the response, then standby router will become active. So what is the roles of standby and what is the role of active? So here, as I mentioned, here we have a two routers. One is R1 and R2. Both are connected. One only elected as a standby router. Second one is a backup router. Backup are it's kind of once active router. Once this primary router is failed, any kind of physical issue, something, then this standby will become the active. It will be wait for 10 seconds. 10 seconds only. Every 3 seconds they will share that information. My neighbor is alive or not. Neighbor is alive or not. If not alive, it will be wait for 10 seconds. Then definitely the standby will move to the active. Okay, anyway, we'll discuss. So election, how it will be elected, standby or active. So first of all, they will check the priority. So by default, the priority every router having 100. Whichever the having highest priority, more than 100, that router always becomes the active router. Okay. If priorities match, then it will be moved to the highest physical interface IP address. Whichever we are giving the physical IP address, it means so this physical interface having one IP address. Let's assume 192.168.1.1 and /24, and this physical interface having fast Ethernet 0 by 0. It's fast Ethernet 0 by 0, and this one also fast Ethernet 0 by 0. You can assume, and this also having the one IP address. And one more thing, these all are the LAN segment, so we should have to take the same subnet 192.168.1.2. So in this case, whichever the having the highest IP address, so one become the elected as a active because highest IP address will become as a active router. If priority is matched, if priority both and 100, that time they will check which one is the highest priority, highest IP address. So based on the highest IP address, they will be uh, elected because tiebreaker is IP address. Here also same thing, highest priority and highest IP address, and here also highest priority and highest IP address are the primary. So in router roles, we have one is active router, one is standby router. Apart from that, if we have multiple routers in our NAV networks, if we it's kind of multi-home network. Apart from that, if you are working in data center, we have a multiple routers also like this. These all are again connected to LAN. One is active, one is standby. Apart from that, all are listening state. Listening. Listening means they will wait. Once active goes down, then standby will become the active, and standby will become the active, and this standby, this listening states again. One will be standby state. Till when the active router came up, if once active router come back up, he will get the rollback. So some kind of conditions will be applied for that. If you want to take a rollback, so we here we have some conditions. What we will discuss those are the conditions. So here one is active router and one is standby router. All are the remaining all are the listening states. So here one is active and all are the remaining all are the backup routers in VRR. And in this case, we have a one is AVG active virtual group router, and apart from those are the four up to four routers. If here we have a listening routers, right? So not like this. Here we have a AVG routers up to four routers. Apart from that, we have a active or virtual forwarding routers. All are the remaining, all are the 1024. So mostly the GLBP gateway load balancing protocol will not use real time. So we will not use the real time. We'll use mostly VRRP if open standard. If we are using HSRP, Cisco Cisco devices. So GLBP means they here we have a lot of things, but the process is very slow. The process is very low compared to HSRP VRRP. That is the reason. So preemption by default, preemption is disabled in HSRP. What is preemption actually? What is preemption? So first, as we discussed here, Here we have a two edge routers, and two edge routers are connected to one switch. This is our LAN switch, and LAN switch is connected to multiple users. And likewise, this is a LAN network up to your LAN, as we discussed. And LAN, these are the LAN networks. So it's ISP connected. These are the ISPs connected. They are connected to one ISP, internet service provider. So this is one R and one, and this one is RC. So this is one is ISP. So this is our LAN, and this one is WAN. So what happened? Here we have a 100 priority, and here also we have a 100 priority. Based on the priority, it won't elect as a active router. It will be it will won't elect which one is active, which one is the standby. Based on the based on the Mac, sorry,